Hi, welcome back to the channel. Thanks for tuning in again today. I'll be looking at that fuel sample that I had and trying to determine, well, unscientifically, I'm not a fuel expert, but I just want to see what can I determine or if I can determine the level of contamination, try and figure out how much water did it take to ruin this fuel sample. And anyway, stay tuned. We'll see what I come up with and we'll go from there. From the contaminated 20-liter container, I was very careful to siphon off from the very top of the container 4 liters of fuel, and I added the food coloring to it, 4 drops. It's all at the bottom. It's all starting to mix back in to form one big droplet. So there is no ethanol soaked in water in this sample. This is just gasoline. What grade it is, who knows? Like the octane rating actually is. The rest of it, every drop that was in that 20-liter container went into this old water bottle. And I put 4 drops of dye also in this sample. And let me move the camera, and there we go. So we can see how much where the color is in the bottom. That's all just plain ordinary water. So here, I'll zoom. There you go. That's quite a bit. I don't know the volume of it. I'll measure it after, but it doesn't matter. If I can only assume, since both of these containers were filled at the same time, maybe there was more water in the other one, maybe there was less. I have no idea. I wasn't there. However, if you put that in an airplane and go to depart, the nose of the airplane comes up, of course, and the fuel tanks on this picked up right off of the floor of the tank at the back. So if there was water in the tank, that's why the engine stopped. Now I've tried to break this fuel down into as many components as I possibly can. And what resulted from that is this container, I labeled it as neat unknown octane, because now that the ethanol is gone from it, separated away from it, I have no idea what the actual base fuel's octane rating is. Now, as far as the ethanol content, then I have the ethanol here that's completely saturated with water. There's a little bit of, teeny bit of fuel on top. It's really hard to separate it all out. And there's basically 1,000 milliliters or 1 liter of ethanol that's completely saturated with water. But there was more water. So this is what was not in the ethanol. This was in the very, very bottom of this container. And it is about 100 milliliters of water, and it's colored that way because, remember, I put the 4 drops of food coloring in it. So this really, I think, shows what I always use my analogy of: we have a sponge, and the sponge will be the ethanol. So we can add water to the sponge or to that quantity of ethanol, and it will absorb it and hold it. But then it reaches the point, just like a sponge, when there's extra water applied to it, that it will drip off. This is how much extra water there was. So we have our completely saturated ethanol right here, and extra water that it would not hold. So this is why I say, if you have even 1 drop of water in your fuel sample, when you check your fuel tank, sump your tank, then this is what the rest of the fuel is like. It's already completely saturated. So not a really scientific test, but I was after just the graphic effect of, what do we have out of this spoiled fuel? Now I'll have to figure out how many milliliters it takes to contaminate this, plus this 100 mils of water, and then we'll see. I could sort of estimate how much water would have to be added to this sample of fuel if it was, you know, new, fresh, and uncontaminated the way it should be. So 90% gasoline, 10% ethanol with no water content. So I'll figure out how much water that would take. According to my research, the maximum amount that this E10 fuel of water would hold is, in US gallons, would be 3 tablespoons of water per US gallon, or in metric it would be 11 milliliters per liter of fuel. So they seem to be, it's 0.41% is what is quoted there as making the fuel what I would consider completely saturated, or the ethanol content of it completely saturated. Now, if I go through this whole, what did I find here? Let's do it in metric first. So I'm going to assume 20 liters of fuel, and then it would take the addition of 200 milliliters of water to saturate the ethanol. Plus, we had an extra 100 milliliters of water that wouldn't stay in the ethanol because it was so saturated. So then I considered this sample, this 20 liters, that it had a total of around 300 milliliters of water in it. Where it came from, I have no idea. But that's pretty much the numbers that I go by that I found. So we switch over and do this in US gallons, assuming 6 US gallons here, then it would take 1 cup to saturate all the ethanol in that sample. Plus, remember, we had some extra water that wouldn't fit in the ethanol, and that would be 1/3 of a cup. So in total then, I would have 6 US gallons with the addition of 1 1/3 cups of water to get it to the sample that I have now. Are my numbers absolutely right on accurate? Yeah, they're pretty close. I don't really know. But it's as close as I could come. And I just really want to get home the point that it will only hold so much water, and then it's super saturated, and then the water falls out of suspension. So if you do your fuel sample and you see 1 drop of water in there, as far as I'm concerned, all of the E10 that's in your aircraft is contaminated, and you need to drain it out. And then put in fresh, and I would flush it through the system right to the carburetors to make sure. Matter of fact, I would take the bowls off the carburetors and let it flush right through to make sure that it's all gone and there's no water in there. Change filter, all the things that you need to do. It's a fuel system contaminated, so whatever is required to clean it, and then put some nice fresh fuel in it that you've tested and you know it's fresh. The sample is nice and clear. It's the way that it should be, and then away you go. Well, you couldn't go flying that day because the fuel system was contaminated. It's actually a good thing. It's a lot of work to clean it out, but it's what we need to do now that we have to deal with this E10, the ethanol in our fuels, our automotive fuels that we use in our airplanes. It's just the world we live in now. That's just what we have to do. It's all the extra steps. So be it. Safety first. Anyway, I hope you enjoyed the video, and like I said, my proportions are probably pretty close. And anyway, like, share, subscribe, all those other things. Smash the like button if you liked it. Stay safe flying out there. Have a great day. Bye now.